All right, so now that we kind of went over the review, I want to talk about some kind of special cases of indifference curves, perfect substitutes and perfect complements. Two kind of indifference curves that won't fit the skateboard ramp shape indifference curves that we just saw with review. Okay, so those would be convex preferences. Now we're going to talk about what's called perfect substitutes, which is a different set of preferences. All right. So Marshawn doesn't really care whether he drinks coffee or tea. He doesn't care about the taste. What he cares about is the overall caffeine intake. Okay, Marshawn works a demanding job. He needs caffeine, and he'll get it whichever way he can. So he's got the option between coffee or tea. Okay. Now, 1 cup of coffee, I don't know if this is really accurate or not, but 1 cup of coffee has 100 milligrams of caffeine, while 1 cup of tea has 25 milligrams of caffeine. So again, Marshawn doesn't care if he's drinking coffee, if he's drinking tea, but if he's drinking tea, he just wants to maximize his caffeine intake. So 1 cup of coffee is equivalent to him as 4 cups of tea. Okay. So let's plot his indifference curve. Okay, so what goes on the axes? Well, it should be the goods. It should be coffee and tea. Okay. Sorry, I guess the line breaks here are a little messed up. But if he consumes 1 cup of coffee and 0 cups of tea, this will yield him the same utility as if he consumed 0 cups of coffee and how many cups of tea. Okay, so 1 cup of coffee, 0 cups of tea gets him 100 milligrams of caffeine. 0 cups of coffee gets him 0 milligrams. So how many cups of tea does he have to get the same amount of utility? So the same amount of caffeine, so the 100 milligrams of caffeine. How many cups of tea does he need to get 100 milligrams of caffeine? Okay, so 25 milligrams per cup of tea. To get 100 milligrams, he needs 4 cups of tea. Okay, so 1 cup of coffee is equal to 4 cups of tea. Okay, so on one axis you have coffee, and the other axis you have tea. All right, and 1 cup of coffee is equal to 4 cups of tea. So 1 cup of coffee and 4 cups of tea should be on the same indifference curve. So these 2 points should be on the same indifference curve because they are different ways of consuming caffeine that will get him 100 milligrams. Okay, so we're going to connect these indifference curves as straight lines. The reason is if you took half a cup of coffee and 2 cups of tea, he would also get 100 milligrams of caffeine, and he'd be equally well off. Okay, it's not going to be shaped like this because that's actually going to, like at these points here, everything in between, that's actually lower amount of caffeine, right? So if you're like closer to here, that'll be like, I don't know. The point is he doesn't care about the mix. He doesn't prefer a mix of coffee and tea because he doesn't care about where the source of his caffeine comes from. He only cares about the overall amount of caffeine. Okay, so let me show you what I'm trying to say here. Okay, so usually the indifference curve is going to be shaped like this, but a point here, which if you had convex preferences, if you preferred the mix of coffee and tea, would be better to a point. This point here would be better to a point like here. They're actually going to lie on the same line now because they're just different ways of getting the same amount of caffeine. Okay, so this point here isn't preferable to this point or this point. So let's say this point is 2, 1/2. Well, 1/2 a cup of coffee is going to be 50 milligrams of caffeine. 2 cups of tea is going to be 50 milligrams of caffeine. So 2 1/2 is just another way of getting 100 milligrams of caffeine. So the straight lines are all just different. They correspond to different ways of getting the same amount of caffeine. All right. So basically, Marshawn has what's called preferences for perfect substitutes. Doesn't care about coffee or tea as concepts. He just cares about the underlying amount of caffeine that he gets overall. So they're completely interchangeable, basically. But they're interchangeable at a particular rate of 4-to-1. 4 cups of tea is equal to 1 cup of coffee. So that's why the slope of this is going to be -1/4. but everything else is going to be the same. Okay. So that's a perfect substitute. It's a good for which you don't care. You don't care about having the mix. They're perfectly interchangeable, except in as much as maybe the rate of change is going to be not 1-to-1. Okay. So he just as well take an additional cup of coffee as he would 4 additional cups of tea. Right. So that's perfect substitutes. Now let's move on to perfect complements. Okay. So I don't know if you've ever seen the movie Good Burger, but it's an old movie from the 90s that I kind of grew up on. So the key to a good burger is it's not really a good burger unless it's got the special sauce. Okay, and you're not going to eat the special sauce by itself either. So you need the good burger with the special sauce in order for it to be good. Okay, otherwise it's just a burger and it's just sauce. Okay, so Sinbad refuses to eat a good burger unless it has Kel's special sauce on it. Okay, if he gets Kel's sauce with no good burger or a good burger without Kel's sauce, he doesn't get any utility. You don't get any utility from packets of sauce. Okay, you don't get any utility from a crappy burger that doesn't have the sauce. Okay, you need both. Okay, it's like imagine somebody who likes crab fries, but they don't like fries and they don't like Old Bay seasoning by themselves. Okay, or you like peanut butter and jelly, but you don't like peanut butter and you don't like jelly sandwiches, right? Same thing. Okay, these are perfect complements, we call them. So they're goods that need to be consumed together. Perfect substitutes are things that are completely interchangeable. Okay. Perfect complements are things that are not interchangeable at all. You can't trade 2 good burgers for 2 packets of special sauce. You want 1 good burger and 1 packet of special sauce. Okay. 2 good burgers and 2 packets of special sauce. Okay. So if you had 2 good burgers and 1 packet of special sauce, well, guess what? That's as good as having 1 good burger and 1 special sauce. Okay. Another kind of like the go-to example of perfect complements is left and right sneakers. Okay, so if you have 100 pairs of left foot sneakers and 100 left foot sneakers and 0 right foot sneakers, well, how many sneakers of those are you going to use? You're going to use 0, right? Because you can't just have 1 sneaker and go around wobbling like a penguin. Okay, if you have 50 right foot sneakers and 25 left foot sneakers, well, how many pairs of sneakers do you actually have? You have 25. Okay. Again, those 25 extra sneakers, the extra right foot sneakers, well, guess what? They're meaningless because, again, you're going to be wobbling around with 1 sneaker, right? So you're only going to want to consume in tandem. You're not going to want to consume the good burgers without the special sauce. You're not going to want to consume you're not going to buy a left foot sneaker without the right foot sneaker. Okay. Unless you have weird feet. All right. Okay, so plot his indifference curve. Okay, what are on the axes? So you should have the 2 goods on the axes. You should have good burgers on one axis, and you should have sauce on the other. Okay. If he receives 1 good burger and 0 special sauces, this will yield the same utility as if he received 0 sauces and blank amount of good burgers. Okay. So remember, Sinbad will only eat a good burger if it has special sauce. So if he has 100 good burgers and 0 special sauces, it's the same as having 1 good burger and 0 special sauce. It's the same as having 0 good burgers and 0 special sauce. Okay, so any amount of good burgers with 0 sauces doesn't matter. Okay, it yields them no utility. Okay, so any amount of good burgers. Sorry, I guess I did it backwards. This is any amount of special sauce with 0 good burgers. 1 good burger and 0 special sauces. Oh, yeah, sorry. No, I have it right. So this is 1 good burger and 0 special sauces. Gives them 0 utility. And any amount of special sauce with 0 good burgers gives them 0 utility. Okay. So basically we can draw a straight line like this. So having 0 special sauces, no matter how many good burgers you have. So this is everything on the Y that's touching this line is 0 special sauces. Any amount of special sauce that you have without any amount of good burger without a corresponding special sauce is the same as having no good burger. It's 0 utility. And vice versa for special sauce. Okay. Oh. And let's say you have one special sauce, okay? So that'd be like right here, here. One special sauce. So this line corresponds to one special sauce, right? And sorry, let's make sure I thought. You have one special sauce. How many good burgers would you need to be indifferent? Wait, I messed this up. Excuse me. It is late, guys. I was a little mad that last example was Marshawn. I forgot that I had it like that. Even when I was reviewing the slides, I didn't click that it was Marshawn. And I was literally just watching the Eagles game as I was recording. I kind of kept glancing over. I didn't miss anything. They suck. But Marshawn used to play for the Seattle Seahawks, as the team that just beat us. So that was fun. So if I have one good burger and one special sauce over here, 1, 1, okay, and I increase the amount of special sauce, I am not increasing my utility. Okay, same utility, so same indifference curve. And if I increase the amount of good burgers, well, guess what? Same utility. If I decrease the amount of good burgers, well, I'm on a lower indifference curve then. Okay, so if I decrease the amount of good burgers to here, well, then I'm on this indifference. Oh, that should be looking like this. I'm on a lower indifference curve. So perfect complements. Ooh, that is not a straight line. Perfect complements should have these kind of L-shaped utility indifference curves. Okay. So when I do the midterm, or excuse me, the final now, when I do the final, I do an example with contact lenses. Okay. The reason I like contact lenses for this is, generally speaking, contact lenses are perfect complements, right? So if I have a bunch of left-handed or left-eyed contact lenses and I don't have a right-eye contact lenses, well, I don't have a pair of contact lenses. But for me, in particular, my vision in the left eye is now apparently the same as my vision in the right eye, even though it was never the case in previous years. But my left eye and right eye contacts are now the same. So now they went from being perfect complements. I couldn't consume one left eye contact without buying a right eye contact, because otherwise I wouldn't have a pair of contacts, to being perfect substitutes. Now I can buy all left eye contacts, never worry about buying a right eye contact, and vice versa, because they're going to be the same. They're completely interchangeable. So that's why I like contact lenses, because it's like having, they're either perfect complements or they're perfect substitutes, and there's really no in between. Because if your vision changes a little bit in one eye, well, guess what? They become perfect complements again. Okay. But perfect substitutes are going to be like this. Oh, that should be a straight line. Perfect complements are going to be like this. All right.